Once again, good morning, general mathematics students. And today we'll discuss the first of two lessons. We'll discuss lesson 3.6, and it's about logarithmic functions. This is an introduction. Now, lesson 3 started with inverse functions. Like if it's xy in one function, its inverse is you just change the x and y. It becomes yx. Now, then we have the exponential functions. These are functions wherein the variable is found in the exponent. And this time, we'll have the logarithmic functions. Now, how is the exponential function related to logarithmic functions? Actually, these two are inverses with each other. So again, the exponential function is the inverse of the logarithmic function. And at the same time, the logarithmic function is the inverse of the exponential function. Let's start by reciting today's memory verse. And it's found in Luke 16, verse 13. It says, "No servant can serve two masters, for either he will hate the other and love the other, or he will be devoted to the one and despise the other. You cannot serve God and money." So again, two things might be inverses in life: serving God and serving money. These two are different, and these two are exactly opposites. They are inverses. What other inverses do we find here? Love and hate. These two are also inverses. And your MVCA boosters is related to this memory verse. Inverses can also be called opposites. Identify one pair of inverses in the Bible and cite a Bible text that talks about each. For example, in our memory verse, it's love and hate, obedience and disobedience. So it's your turn to find one. At the end of today's class, you'll be able to do three things. First is we represent real-life situations using logarithmic functions. Second, we distinguish a logarithmic function, equation, and inequality. And the last one, I place their prerequisite concepts because it's not in the set of learning competencies, but you need to learn about this. You need to learn how to rewrite from exponential to logarithmic, and also from logarithmic to exponential. Here's one of the applications of the logarithmic function. If you noticed, once there's an earthquake, the news will declare it, or FIVOX will declare the earthquake is in magnitude 5, magnitude 5.7, magnitude 6, magnitude 6.8. The main question is, how did they compute for the magnitude? Now, the magnitude can be measured through the Richter scale. In this Richter scale, you'll see here in, what's this? In the graph, there's a 0 magnitude, not felt, 3 to 4 minor, 5 small, 6 moderate, 7 strong, going to 8 major, and going 9 is great. That is how we qualitatively interpret it. But how do we solve for the magnitude using the Richter scale? Now, there is an instrument called seismograph, which measures the magnitude of the earthquake. But if you'll ask me, how did the seismograph work? It's based on a logarithmic formula. And here's the formula in solving for the magnitude of the earthquake. That's 2/3 logarithm of E. It means the energy of the earthquake released in joules over 10 to the power of 4.40. The answer to that will be the magnitude of the earthquake. We'll have more of that during the problem solving. Now, what is a logarithm? A logarithm is an exponent which b must have in order to produce y. For example, remember in our exponential function, this is the general formula. F of x is equal to b of x, or we say y is equal to b to the power of x. X here, the exponent, is called the logarithm. What must be the value of x in order for this expression to get the value of y? So again, x, or the logarithm, the value of the logarithm is your exponent. And remember that b must be a positive number and must not be equal to 1. Now, what's the general formula for logarithm? Here is the general formula. That's log b of y equals x. Again, log b of y equals x. Now, here are some notes to remember. First, b is called the base, whether it's in the exponential form or it's in the logarithmic form. B is called as the base. In the exponential form, x is called as the exponent. In logarithmic, x is called the logarithm. Next one. The logarithmic function and exponential function are inverses. So if we have xy here, in the other we have yx. We just interchange the x and y coordinates. Next one. In the logarithmic form, the value of y cannot be negative. Again, this one. The answer to this should never be negative. If you want to check, try using your calculator. You press log -1. It will not give you the answer. Y is called the anti-logarithm. And the last one is the value of x cannot be negative. So the answer to this must never be a negative. It's always positive. What else? We have what we call common logarithm. If you notice in your calculators, you have only log and then this one in a 2-line calculator. In a 3-line calculator, you have log, a box on this, and a box on top. It means you can write any number there and any number here. But for some calculators, you're not allowed to write a number here. What does it mean? It means that your calculator can only solve for common logarithms. In common logarithms, the base is 10. So you write 10 in the base, but it can also be written without the base. So just log x. So if you could not see any base in your logarithm, then it means that the base is 10. Now, how do we have the basis of 10? Example, 10 squared equals 100. 10 cubed equals 1,000. So if I'll solve for the logarithm of 100, the answer will be the exponent, 2. If I'll solve for the logarithm of 1,000, what's the exponent of 10? 3. And that is how the common logarithm works. We also have the natural logarithm. Now, in the exponential function, the natural exponent is called e. In logarithmic function, the natural logarithm is called ln. Again, it's not in, okay? It's not in, it's ln. So that will be our natural logarithm. So example, if you have log e of x, you can simply write it as ln of x. Now, what are some applications of logarithmic functions? I told you a while ago that the magnitude of the earthquake is 1. Second application, the sound intensity, like how loud or how soft is the sound in decibels. That can be solved using logarithmic function. The other one is the acidity and the power of hydrogen scale, like the pH scale. How do we solve for the value of the pH scale, whether it's acidic, basic, or neutral? We can solve for the power of hydrogen using a logarithmic function. Now, let us have some formulas. Let's start. Ready? The first one. Suppose that an earthquake released approximately 10 to the power of 12 joules of energy. So this is now our energy. What is its magnitude on a Richter scale? Okay, so remember the formula for the magnitude. That's going to be R equals 2/3 times log E over 10 to the power of 4.40. What's the answer? That's 2/3 times log. Our energy is 10 to the power of 12 joules over 10 to the power of 4.40. Give me a moment first. Okay, so solving for that one, you'll get a magnitude of 5.7. So it means that the magnitude of the earthquake that releases 10 to the power of 12 joules is 5.7. It's considered as moderate, right? In the Richter scale. Next application is on the decibels, or the sound intensity in decibels. Now, how do we solve for the formula for the amount of decibel or decibel level of sound? We have this formula. That's D equals 10 log of I. I is your intensity in watts per meter squared over 10 to the power of negative 12. Now here, the least audible sound a human can hear is at 10 to the negative 12 watts. That is why it's the denominator. Now, here's the question. The decibel level of a sound in a quiet office is 10 to the negative 6 watts per meter squared. What is the corresponding sound intensity in decibels? So let's solve. That's D equals 10 log, what's our intensity? That's 10 to the negative 6 over 10 to the negative 12. You can solve this one time using your calculator. And the answer is 60 decibels. This is now our answer. Any questions? Let's go to the next one. Now, it's the same as the other one, the last. The acidity and the pH scale. Remember in your science classes that the pH of 7 is described as neutral. If it's below 7, it's acidic. If it's greater than 7, it's basic. Now, how do we solve for the pH level? The formula is pH equals negative of log times H positive. H plus is a concentration of hydrogen ions in moles per liter. So for example, in a water solution, in a 1 liter, it must be in 1 liter, or else you need to convert it. In a 1 liter solution, it contains 0.00001 moles of hydrogen ions. Find its pH level. So the formula is pH equals negative log of H plus. Our H plus is 0.00001 moles. Have the negative log of that. The answer will be negative of negative 5. That is positive 5. So how do we interpret this? Based on our description, it is acidic. So state that the concentration is acidic. Now, let us have the distinguishing of logarithmic functions, logarithmic equations, and logarithmic inequalities. Remember that if a logarithmic expression is equated to f of x, that is called a logarithmic function or equated to y. While if it's equated to another variable or another number, it's called logarithmic equation. And with the inequality sign, we call it the logarithmic inequality. But again, you need to remember, your base should never be equal to 1, and your base must be positive, greater than 0. Another, your anti-logarithm must be positive. Examples. Okay, using your chat boxes, can you tell me whether number 1 is a logarithmic function, a logarithmic equation, or a logarithmic inequality, or none of this? Ready? With your chat boxes? With your chat box, can you tell me what is the classification for number 1? Very good. It's a logarithmic function because it's equated to f of x. How about number 2? 5 equals log 6 of x. Number 2. 5 equals log 6 of x. Logarithmic function, equation, or inequality? Very good. It's a logarithmic equation. How about number 3? Number 3. 2 is greater than log 3 of 9. 2 is greater than log 3 of 9. That's great. Logarithmic inequality. How about number 4? Number 4. B is equal to log 3 of 243. B is equal to log 3 of 243. Number 4. What's the answer? It's not equated to y. So it's not a function. It's a logarithmic equation. Next, number 5. Log 6 of y is less than log 6 of x. Number 5. Log 6 of y is less than log 6 of x. It's a logarithmic inequality. Very good. And the last one, number 6. F of x is equal to log negative 6 of x. Here. Oh, very good. It should be none of this because you look at the base. The base is negative. So it cannot be a logarithmic expression. So we say none of these. Very good. I think you're ready for the first quiz of the day, of the last one. How do we rewrite an exponential function to logarithmic equation? Here's how we do it. This is the form for exponential function. Once you write it to logarithmic equation, the base becomes the base of the logarithmic function. The exponent becomes the answer. And the answer in the exponential equation is your anti-logarithm. Let's have an example. Here. Let's start by writing log. Log. What's the base? 3. That's the base. What's the answer? X. Equals the exponent, 2. That's it. Another. What is the base? 3. What's the answer? 81. What is the exponent? Equals x. Next. What's the base? 10. What's the answer? 0.01. What's the exponent? Negative 2. And since you have 10 here, it's okay not to write it. The next, what's the base? 4. The answer, 1. The exponent, 0. Any questions? Let's do the other way around. Okay. Base first, 25. The answer is the exponent equals the anti-logarithm. This is the last. Next, base first, answer 3/2 equals the anti-logarithm 27. Next one, base first, 1/2, the exponent to the power of negative 3 equals the anti-logarithm 8. Let's know the answer. Any questions before I'll go to the next topic?